what is NMP and what is NAP. There are principal differences between these two tunneling methods. So when you use an RMR Q system, it is not any longer NAP. But when you do fencing, so then you may also say it is NAP. So therefore, this Norwegian method of tunneling is not that much highlighted on the road. So therefore there is a confusion about it. So therefore I wanted to discuss what it is about. Okay? Many things that Q system is only NMP. This is also not correct. Okay? So during this my 30 minutes presentation, I will discuss with this 5 issues and conclude my presentation. And you see here, third, in 1971 from there up to now, Norway has all the statistical records of tunneling. And since last 60 years, there has been almost 60 kilometer tunneling every year in this country, even though it's a small country with respect to population, it has only 5.5 million people. But with respect to per capita tunneling, I think it is among the first in the world. And if you see here in this figure, you see at the beginning, the main tunneling activities were for transport. So after Second World War, Norway was in high time in developing energy. This is what we are doing today in Nepal. But what is the difference in a place where Norway is that Norway utilizes rock mass as a body that can sustain itself, so to minimize the support load. If we look here, 97% of hydropower tunnels and shafts are online. Not only headrest and tailrest systems, but also incline shaft, vertical shaft. Optimize rock support in road and railway tunnels. We don't use unnecessary support. We have to optimize as much as possible. Almost no concrete lining, excluding few in the urban areas. Otherwise, all tunnels are shorting. What is the Norwegian method? Why it is called Norwegian method? Is that it is totally different than in other areas, the way we make tunnels. So first, NMP basis on the fact that each stress increases the confinement of the rock mass, meaning the natural stress give more friendly environment to the rock mass because they will tighten the joints and then it will be able to sustain itself. There will be a if we have jointed rock mass, the withstand capacity is enhanced using rock support that means bolting or anchoring and application of steel fibers. So then we help rock mass to withstand itself. So this is the approach we should do here in this country. And then mostly this thickness of the fiber is less than here. And one another thing that we do to seal the joints is to apply pre-injection. We do umbrella injection so that all joints are sealed and there is less seepage or leakage. And if weakness and fault zones with swelling potential are made for water tunnels, so then in those sections, in addition to structured line tunnel, we do the concrete line. Only the small sections, maybe 15-20 meters. And then they might be regular. And whereas if weakness and fault zones are made in road and railway tunnel, the combination of systematic bolting and RRS, reefs of reinforcement, circuit, are so then we don't need any concrete. Therefore, NMP uses empirical relations and numerical modeling to make sure that stability is there for a long-term perspective. Any other rock mass classification only use. But here we can. It is better to use more than one rock mass classification system to have more geological records. And also rock support decision during planning and construction phases, but few systems supports that gives only preliminary. which is part of the permanent support. And then the permanent support is decided based on the overall rock mass quality conditions and some verification will be made to the model, and we may add some additional layer of sorting or some bolting on that. So this is how we define quality. And when we do this, we use this approach, there are 4 steps we should be careful with. That is how to fix the location of the tunneling. Failures in Nepal regarding tunneling and problems during construction is related to the location. So we have certain areas which are fixed with the public sector, there are coordinates fixed. Within that period, we should place our underground structure in such a way that we have minimum possible distance. So therefore, location is very important. I will go through that. And then shape is also very important. We should make easy shape so that it is much easy to establish and to install the support and to utilize it. And then of course site will depend on what purpose of the construction. So all these 4 issues will govern overall mass quality assessment and cost implications and construction time issues. So if we go through the Norwegian hydropower tunnels and shafts, equally related here. So this is the first one, small hydropower projects. Generally they have powerhouse outside, and then long line the lower tunnel, and then online the tunnel. But here most likely we use tensor, and then there is system online. And then all structures are underground to powerhouse is inside the mountain. This is very important for Nepal also. We have experienced back in 2015 what happens if we put powerhouse to the surface. So there was a huge damage in Pategosi, for example, but none other projects that had underground powerhouse, they did not suffer any problem. So it is not only related to hospital but also for long-term safety, because gold is dangerous. We don't know who will hit when, what kind of sickness. So therefore, to put energy system inside the mountain is very, very important, as long as it is possible. So it is not compulsory, but the topography and geology should allow. And then we have also one special type of construction. You see here, this is a lithium project where it has maximum online static, which is 10.5 megapascal, 1050 meters. I will show you later. And here, what kind of decision we have done is that there is a underground powerhouse and then a small lower section of the minister, and then this 10 kilometer long headbridge tunnel goes to the headworks directly. I pressure tunnel online. Okay. And such construction we have 10. So as I mentioned, all hydropower tunnels, they are 95% online. Location and orientation design is quite considered. That makes quite a lot of saving in the use of support. And it is very important to have more inch-to-inch information, especially if you want to have online pressure tunnel or pressure shaft system. So you should have minimum principal stress more than static water pressure. So we also use one of the projects here, which is Kathmandu, which has a static head of 150. That is considerable. So it is possible to increase that also if we do planning in a better way. And Q system for rock mass quality evaluation and preliminary rock support is important. And if we look at the development stages, you see here since 1950, during First World War, there was a huge scarcity of steel, and Norway did not have any mines for the production of steel, so then they needed this energy. So they built 5 such plants, and 2 of them they partially failed, but the other 3 still working very well. So then from there they learned how to do the online system of the tunnels. And then after Second World War, so there is a boom in hydropower energy development in Norway because you need energy to be utilized. You need energy to warm your houses. You need energy to cook your food. So electricity is the best way because it is available in our home country, right? Like in Nepal. So this is very important. So therefore, development of energy is very important, and minimizing the use of money is also very important because we should use these resources in other areas. So there is a stepwise development of the online settlement system. See here. So in 1960s, there was almost 350 meters after K3, after K4. It was a record breaking in 1965, and then it went up all the way to Lithium, which has a scale of 1048 meters, which is almost 10.48 megapascal of the station. That is taken care by the rock mass itself. There is no reconstruction lining in this tunnel. And important thing is that all rocks are belong to halite and gneiss and some schist. Similar to this. What is important is how to design is very important. Okay? So when we locate online waterway systems, so in Norway there are mainly three principles that are being used. But nowadays we are considering to have a different approach because there will be more development of hydropower, because there will be pump storage plant coming more. So then we have to look with the different topographic situation. So most of the tunnels that were or hydropower systems that were developed in Norway has category 1 and 2, not category 3, or other side valley is not yet as deep. We have these 4 criteria to be used here. So first, this vertical height to the online shaft should be more than water pressure divided by the density of rock multiplied by this inclination also. As long as we have this criteria met, it is very unlikely to have hydraulic jacking or cancelling. So then, same principle will be applied to water pressure divided by. And then, what is important is that once we reach nearby power house, we should make sure that our minor principal station is more than the station of water pressure. So these are the principles to be used to locate the power plants or underground systems of the waterways. And then when it comes to placement of power house, for example, say we have 2 rock formations, typical pressure tunnel system, mine pressure tunnel shaft system. So what is important is to put the powerhouse in a correct position. So for example, if we have a boundary fault here between 2 rock formations, so if we put this powerhouse on this side, what will happen is that this block is the distress block. We will be having more branches of mass somewhere in from the boundary fault. Then we should achieve minimum distance that is required. That can be fixed with numerical modeling. So what is important is how numerical zone needs to be considered very well. In situ stress information will need to be measured here. Once we cross this area, we can do 3D stress measurement to have all 3 tensor of the in situ stresses, and then that will be helpful to do the stability assessment of the underground power station, which is also online or big line, so that we achieve the minor principal stress more than static water pressure if we would like to have online pressure control system. And then this is an example of numerical modeling. Today we have very strong computers that we didn't have in past in 70s, so they have to make a small use room with a photon programming house, and then they made different charts by making numerical modeling, and then they were using these charts. But nowadays we do the complicated numerical modeling in in our laptop sensor. You see here how it works. So for example, if we don't have any shear plane or it is shown here along the waterway system, so the minimum principal stress are much higher than the static head of the that is coming to the head system. But once we introduce this shear plane, so then minor principal stress drastically reduces, because shear plane or for zone are the areas where we have more shear movement, meaning top mass is distressed. So it means minimum principal stress will be reduced drastically. When it comes to orientation, so always we should try to develop 20%. Do the mapping as much as possible and have a good statistical variation of the major joints. What we do most of the time is that when we do mapping, we forget about major jointing system and mostly we measure random joints that are made along the roadways. So you should be careful with that, so that you have major joint system are cast when we map. So this is important according to the topographic condition that is available there. So option 1, option 2, okay. And if there is no possibility to have sustain, so then we should always make some or more than 30-35 degree with respect to foliation or bedding bench. Cross lines once we are into the mountain, some cross lines may be disappearing or spacing will be increased. So this is the way we should orient the tunnels and caverns. And also we should make sure that if we have stress measurement, so this needs to be checked with respect to alignment as well. And when it comes to shape and size of hydropower tunnels, so most of the tunnels and caverns in NFT are inverted because we use mostly brilliant glass tunnel, which is the case here also. Most of the hydropower tunnels are built with brilliant glass. And brilliant glass method is the dominating excavation method in Norway. But in 70s and 80s we had a booming TBM tunneling, and Norway made many records of TBM tunneling in that. But if we collect all these excavated tunnels, so there will be about 5%, about 300 kilometers of the tunnels were built, hydropower tunnels were built with TBM. And there was attempt to use the road tunnel. One of the road tunnel was excavated with TBM, but it was not financially viable because it is circular and you have to make unnecessary extra sides, or you have to cut later side, so which is very tedious and time consuming. So therefore, the TBM will phase out once most of the hydropower booming is completed in 1990s in Norway. But now there are some tunnels that are built with the TBM or railway tunnels, because in railway we don't need to cut side. So otherwise most of the tunneling is brilliant glass. It will be same case. There will be some basic transfers to the projector, two of them are completed, so it was okay for that. And maybe if we have very long tunnel system, we may use TBM. But TBMs are at least 2.5 to 3 times expensive than brilliant glass. What is important is Nepal should use the technology to do the good brilliant glass tunneling, because the present practice we do is insufficient to have a very efficient brilliant glass tunneling. So, if we look here, the size of underground opening is dependent on the purpose of construction. Of course, if we have a headrest or tailrest or axis, not like we have tunnel will be like this, but for powerhouse we will be having a shape like this, but it's a roof and then the wall. Otherwise, we might have also transformer cavern inside. So then we should have sufficient distance between them, so that there is no distressing situation between the two caverns. So we should make sure that we have a good pillar in between. So that can be fixed with the numeric. And then when it comes to road tunnels, so this is a typical theoretical section. but when we plant, it won't be like this. And then you see here we have a concrete element here, and then there will be either concrete element to the top, or there will be E movement circuit. I will show you later. And then there will be always gap between the rock wall. E is a polluting thing. So I will show you. So road tunnels in Norway are also not efficient because flow will be much faster, and then we might have also two tubes. And then the size depends from T4 to T40. T4 means 4 meters width and height of the tunnel. These are very small tunnels in the remote areas where we have very low traffic and very short runs. And then this T14 is the maximum sized tunnel that will be found in the city areas. So if we look here, you see this is the table, how Norwegian road tunnels are built. So we don't have any safety tunnels like we have it now. Okay. So I commented about it because if we have to build a safety tunnel, why we should not increase the size so that we have two tubes tunnel and then connection in between, then it will be useful for both trucks and other normal traffic. In one tunnel we could send small traffic, small vehicles, bus and cars, and others with motorcycle and trucks. That should have been much easier. Now there is no possibilities to bring any heavy trucks through the tunnel. So what is the reason of building this? I don't understand. So see here, the tunnels are categorized in different. So if we have less than 5 km tunnels, so then we don't need any bypass. And if we have tunnel length between 0.5 to 4 km, so then every 500 meters we should have in large area. If there is something goes wrong, so then we can have a possibility to return the vehicles or to make stoppage there. And then if the length is 4 to 8 kilometer long, so this emergency area will be reduced to 375 meters, and then turn around 500 meters, and then like this it increases. So once it reaches between the vehicle movement of 12,000 daily average annual daily traffic 12,000 and more, so then we should have. And then you see here I have noted here, if tunnels are longer than 10 kilometers, special considerations are given. Meaning we should have more investigation, more investment in finding out the quality of rock, and then certain safety criteria should be enhanced. Evaluation of rock course, rock spalling should be made based on this criteria. And rock mass quality evaluation and SRF needs to be quantified correctly. With this, let's come to the construction and rock support measures. I have talked quite a lot already. So you see here I am standing in outcrop here. So this is Kalai. The foliation is coming like this. And then this chunk of rock is very famous in Norway. Many tourists visit every year. And then it is standing itself. Okay? Even though its compressive distance may be 30 to 50 megapascal, which is the case in our most of the rocks are much stronger than this. Okay? So, fully mechanized drilling blast method is the essence of NMT, of course. And rock mass has its own capacity. I repeat again, NMT utilizes rock mass capacity as self-source. Okay? Meaning, substantial load is carried by the rock mass itself. And then, if we look on the support system that we use in tunneling, there are 3 approaches. One is scaling and anchoring, of course, which is the first step we do. And then, shall we use flexible support or rigid support? Depends on the method we use. So, if you use the NACA, most likely you will end with this. This is the practice right now here, which is very uneconomical and unfriendly in my opinion. And then if we use flexible support like reinforcing factor rock mass with the systematic bolting and steel fiber circuit, that will save quite a lot of time and cost. And this is the way forward. So this is the Norwegian way, and this is the way that is being used here currently. So I would encourage we should remove all the loosened cloth of the glassing. And then apply spot bolting immediately if there are some hanging cloths. And then make clear and do the mapping and then apply this circuit. This figure is taken by my daughter. This rock is quite weak, similar to the or even weaker than most of the rocks we find there. And this is a fully circuit line system here. And then this is the combination port that we use. And pre-injection is another way to save the money. Long holes and then do the pre-injection grouting to make a sealed area of the tunnel. And the typical grout mix could be this, and then this will enhance the quality of the rocks. And then this is for the typical ground condition area. So we can use spiraling ports that are hooked with this channeling. And then we can use RRS instead of steel ribs. So we can have single layer of the reinforcement or double layer if we have extremely weak rock. This is much faster and much easier. And this is the practical application of the RRS. You see here. And this spiraling body. And when it comes to groundwater and thrust control, so this is the way that I discussed. So this is the circuit line and the reinforcement. And there is the concrete element and T, O, and circuit. So different types. You see here, if we have low level of vehicle movement, so you just use T, and then finished. And if we have a high density of the regular movement, so we should have concrete elements and the circuit support to the top. Behind there is a P form. So circuit is applied against fire. And then we may also use both the concrete element to the wall and to the with a gap in between. Or another is of this full concrete line. This is what is done at Nalgunga and this first step. It is very seldom used in Norway. And you see here, this is the application of concrete element with the mechanized.
So giant circuits are
necessary, right? That's it. And then this is the gap. You see here. This is we have this membrane, and then below we have concrete element, and it is hanging. And this is the circuit supporting working the tunnel. They use gaps. If we do the concrete line, we should help. So, and I will go to the next. Why MT is necessary in our life? Use of rigid support system and final concrete lining is possible. And time. And rigid support and final concrete lining are inherently unfriendly. And we must remember that CO2 emission from the concrete production is directly proportional to the cement. And content used in the concrete. So 900 kg CO2 is emitted by producing 1 project or 1 ton of cement. So therefore it is very important to reduce this amount. And limiting use of concrete is very important for not only to protect the environment but also to make cost effective and sustainable tunneling in Nepal. So with this, these are my conclusions. So you have heard of it. So NFT is cost effective, sustainable tunneling solution and is an important means in the reduction of carbon. So we have to think about it. So it's also and this is the next part. This is the whole longest tunnel. And every 6 kilometers there are illumination like this. So it is undersea tunnel. Okay? When do it tunneling and it is all volcanic rocks by the plastic lava is in parallel. Okay? So I recommend not to use it. Okay? So it does not make sense to make tunnels like this. I completely disagree. So with this, I conclude my presentation.
Thank you.
State that in some tunnel, which are approximately around 500 meter to a kilometer long, sometimes the cost of partial lining in the inlet and outlet is equal to or sometimes even exceeds the full concrete lining. And I have the data from my experience because of the change in supports, additional supports and change in formworks of the tunnel. And also I have a query in terms of rock support. Is a client working in Nepal. How can a client justify the use of inadequate support? Let's say if deformation arises, how can a client justify a variation when he takes the risks and doesn't provide adequate support in the tunnel? How can the variation be justified? Because then we will have various policy and other problems. So isn't it good to stick to the safer option rather than risking variation in case of deformation?
You see, no matter whether you concrete line or not, you have to use the luminous rock support so that people can do the tunnel. What is NMT is that this part of the support, which is a combination of systematic welding and circuit, so this is considered as a part of the permanent line. Okay? And then you add extra layer of the circuit after you go far ahead of the tunnel excavation, you can do parallelly behind. So, and when it comes to the deformation control, so this here we use quite a lot of this steel grip, which is inefficient to hold the deformation. Most of the steel grips are twisted, and if there are many examples of twisting of the steel grips, but if you use RRS, it is much stiffer, and then it will work in combination of the systematic welding, and it is much better to control. And once deformations are controlled, they will be permanent. They will not be grip for very long. Okay? During construction, most of the deformations are done because this stress redistribution has already occurred.
Thank you, sir. Thank you. We are out of time. We thank Professor Panti for his very good presentation, and we invite our next speaker, Dr. Suman Panti. Their title is Assessment of Blasting Vibration and Adverse Impact on the Underground Support System and Surrounding Structure.
As Professor Panti said, there are a lot of works in using with drilling and blasting methodology. A lot of hydropowers and drilling works is going on with these drilling and blasting methodology. And these are the outline of my presentation. The sensitivity area, vibration, and monitoring and impact of blasting and irrigation and conclusion. So this is the underground excavation cycle. What we have started from building, then charging up blasting material, then blasting and ventilation, working, scaling, and ground support system and surveying mapping. So drilling and blasting is most common where various size of drilling is required, and it is one of. But in drilling and blasting, there is always associated with unavoidable negative effect, that is ground vibration, overbreak or backbreak, noise and fire. Among all negative effects, they are major concerned with ground vibration. Ground vibration to the surrounding structures and habitats, which are living surrounding to the where the living works is going on. So for ground vibration, it is mainly depends on rock mass properties and blasting parameters. So we cannot change the rock mass properties. So we can only play with blasting parameters. This is our study area. This is where Nepal, because of that, this is our river, and where our project is under construction. And this is portal opening for main access tunnel, and our caverns are somewhere here, and this is the shaft, and outfall area is associated with This is a small video. This can show how the firing works using explosive is going on. So study says only 7 to 25% of energy, 27 to 25% of explosive energy is used for fracture and removal of fracture fragments, and rest amount of energy is vanished through the heat, smoke, and seismic vibration. And so these are the when the seismic wave generated and moved through. How we have to, if there is blasting, and we have to measure over here, and how the propagation of seismic wave, that is in the form of body wave, we know body waves, T waves, and S waves, and surface waves. So here how the body waves move and with their relation with propagation, and how the surrounding particles behave with the body wave, that is P wave and S wave, and thereafter surface wave, how these waves are propagated and the particle with relation with the surface waves. And ground vibrations, these are also type of shock waves or seismic waves that are traveling to the surrounding rock mass from explosion in the blast zone. And shock waves are decays to an ordinary stress wave rapidly, since rock is inert material. Then if we go apart from where blasting is going on, then we go to distance from over there, then shock intensity is coming low, and from the PPV value we can calculate the damage zone. How what are the negative effect of the blasting and cell impact in the tunnel to the damage zone? What are the beyond the desired or beyond the whole has been area has damaged. So this is the damage zone, and if PPV is low, you can illustrate with this graph. If PPV is low, then damage zone should be less. And for this that calculation, we have to use Holmberg and Pearson relation with these parameters, P wave velocity. We have taken through the laboratory studies, P wave velocity, young modulus, cancellation, and critical PPV from our equipment. And if we go through a single blast hole geometry, so there is explosive in the center, and this is the original wall before the blasting, and hereafter, after blasting, there is expanded wall due to blasting effect, and this is the crush zone, and radial cracks are generated. This is only single blast of geometry. But we can easily understand the rock mass damage beyond the proposed or designed tunnel section, fracture zone. Damage to nearby structure, that these cracks are damage to nearby structure, and by these cracks, effect in support system and cracks in shotcrete, concrete layer, and attachment in the rear piece of the tunnel. And if we go to the design profile, and where the proper blasting pattern has been fired, then this is the desired profile or design profile. Then this is overbreak zone, and this beyond the overbreak zone is the disturb zone. Beyond the overbreak is the first damage zone, and then disturb zone. And after these are electrical blasting that cracks in the shotcrete in the rear edge, and if blasting is uncontrolled, then there are some cracks in the habitat building also. And to reduce this ill effect of the blasting, how we can mitigate that? So use our smaller diameter of blast hole, means number of holes is larger, number of holes is larger, and burden should be small. So we can take small hole for the excavation, shorter length of blast hole. To divide one blast into multiple blasts, we can, if rock strata is not good, then we can go through central granite and then widening, etc. to avoid simultaneous multi-hole initiation and the beginning. So we can use different type of series. So minimum distance to the beyond the excavated area. To employ decoupled charge, different type of series has been used for the excavation, and to use the multi-deck charge for the different. So how can this is the plastic source. How can we use the negative effect of the blasting? In first way, we can reduce original stress wave by explosive quantity. So if there is one larger quantity, then waves are wave velocity and frequency is high. Then if we use the whole B where small quantity is used, then then it can be easily with a smaller velocity and frequency. Then in second case, we can use different type of series. Then wave should be superimposed to first delay, first wave is going on and second wave is going on. Then in third case, if there is fractured area, then wave velocity and frequency shall be reduced to reach at the inhabited area. In fourth case, for reducing the negative impact, we can use slot or free splitting for that, so that vibration can be travel less to the beyond that.
Please complete in 2 minutes.
So this is the DCMS guideline for that. Here we can control with peak particle velocity with the frequency. So if peak particle velocity for the domestic house or nearby, these peak particle velocity should be less than 5. For the dominant frequency, less than 8. So this is the DCMS guideline. And for in our project, we are taking the blast monitoring. We are within this guideline. So these are our blasting events, and these are below as per guideline, below these boundaries. So in conclusion, ground vibration, trade-off are the major undesired effects of blasting cause damage in rock mass support and environment. To minimize the vibration impact, blast design properties with considering rock mass properties as mentioned earlier, we cannot change rock mass properties, but we can play only explosive properties and blast design parameters. So for that question, we have to found that damage zone for that particular event is less than 0.4 meters. So for the design support, we can plus 0.4 meter. So this effect can be neutral. If damage zone is increased, then effective design support is decreased. If our rock board length is fixed 3 meters, and then damage zone is 0.5%, then we should go with rock board length of 3.4 meters. In last vibration study, more efficient extension progress and minimum damage to surrounding rock mass can be achieved by blast design optimization.
Thank you.
And have you considered any specific explosive parameters such as the bulk, strength of explosive and that gas formation, all the technical parameters? Because in your presentation, I think you've said that there is a blasting pattern needs to be optimized, right? But the plastic patterns such as burden, spacing, soft drilling, and stemming, all these things are not, I think, find it there.
Yes.
And do you specifically from your study, can you specifically recommend any technical specification of the explosive material?
In this table, you can see the burden, spacing, charge, stemming, drilling holes, number of this table is given.
Ground vibration or earthquake is usually not covered in the underground structures because surface structures there is a risk of earthquake and ground vibration. But considering that if there is a certain side cover or overburden, then we negate that during the support design. So what is your findings, ultimate findings regarding the study that dawn vibration, does it affect adversely and how much?
Actually, earthquakes are seismic are not considered in during underground tunnel. But if we consider the caverns where the cover is low, in transformer hall and powerhouse cavern where cover is 100 or 150 meter, then it's okay. And if there is nearby surrounding civil structures, then we should go for these blasting vibration studies, so that our blasting pattern or blasting activities has been controlled. So the minimum effect to the surrounding structures and surrounding habitats.
Thank you. We are out of time. Please continue your discussion in the break time. And we now...
The distance from the road. That's why it justifies the significance of road in terms of socio-economic development of Nepal. And most of the strategic highways in Nepal pass through the river valleys and some steep mountains, and that poses the threats of slope failures during the rainfall and the earthquake. And for example, about 46% of the Prithvi Highway road section that passes through the steep mountains and which contains numerous cut slopes. Likewise, the Krishnavir landslide that is 83 km west along the and that disrupted the road and 10 days of completely disconnection with the capital city took place in Nepal Himalaya from 1971 to 2020, causing 500 mortalities with an average death of 111 every year. And the high fragile toll laid by the disposition of crossing, especially by the MCP and within the MCP and MPT have made slope failures very common in this zone. And the continuous rainfall on September 26 and 28 of 2024 also caused more than 500 landslides. Only along the Prithvi Highway, on the Chandramala landslide at 70 km from the deadliest one, where 35 people died while traveling through the crossings. And this is the case history from the Koke landslide. It is situated in the Gorkha district. And it's and this is the location. This one is 11 km from the Gorkha. And this is the actual landslide that was before the 2009. Now every year it was aggravating. And in methodology we have used the three methods, as I have already told. I have used the limit equilibrium methods. It determines the factor of safety. And another one is the finite element method, and it determines the maximum shear strain area, and also determines the stress reduction factor. And the next one is the particle finite element method. It's the PFM, as already Mr. Vidas told. It gives us the runoff distance and the sediment height. And the interface is the GI amount equipped with the practice visualized to be at the pipe. Limited method is the very basic methods. In this method we use the flint methods to determine the factor of safety. And especially the failures and the circle method, I use the initial method adopted for the limit equilibrium analysis. That is usually used for the circular slip transfer. And the other advanced methods like the Morgan's price method and Sarma's method that are used for the force and moment equilibrium. And that have been developed to improve the accuracy of accuracy. And another one is the developed by the Bishop method, that is considering iterate information for its solution. And the Jandu method is used for analysis for non-circular failure analysis. Sometimes the failure analysis might be non-circular. And finally, the method, unlike the limit equilibrium methods, FEM doesn't require any prior assumption regarding the shape and the location of the failure surface. However, failure naturally emerges along a surface where the material strength is deficient of resisting the applied shear stresses. And another major advantage of FEM is its ability to incorporate shear strength behavior in the progressive failure. FEM enables the tracking of continuous deformation and failure evolution, and makes this method very highly effective for capturing the progressive failure mechanism. FEM is a very robust tool, soil behavior with different loading and environmental conditions. And it provides the valuable insight into deformation and is highly effective for evaluating the both sort mass age. We can see in different time variation, we can see the regeneration of the regression after the deformation of the dome. And these numerical methods contains the pre-failure analysis and the post-failure analysis. In the pre-failure analysis, we have used the limit methods and the finite limit methods. And it determines the factor of safety. It's a deterministic approach. And the finite limit methods, it determines the stress reduction factor. And in post-failure analysis, and I have used the PFAM, I have used the DMO. It's a element. And this PFAM determines the runoff distance and the deposition segment deposition height. This is the soil characteristic of the caverns, right? And the cohesion I have used in two conditions. Trial condition is a normal condition at 10% moisture content. The cohesion is like this, and this is the value for the external parameters. And where the 80% of the 80% moisture condition and cohesion reduces from 18 kilopascal to 4 kilopascal. And friction reduces from 12 to 14. And what will be going into this slide? And based on these soil strength parameters, I have done some numerical modeling. And this is the electrical resistance to one practice that was carried out along the center part of the landslide to determine the subsurface condition. On the basis of this, model is created based on this information from this DR. And this is the this one is the LEM method. In the normal condition, the factor of safety is 1.85 to 853. It indicates that it is stable. And in the this is the projected factor of safety because it's less than 1. When it gets less than 1, it is unstable and it goes down. And in what condition, when the moisture content is 80% or more than 80%, at that time the projected factor of safety is around 0.761. At this stage, then the landslide takes place. And on the basis of the ground water table over here, that is defined from the ERD, and with the application of some Gaussian wall over here, in the wet condition as well, the factor of safety was found to be 1.369 in the wet condition as well. It's critically stable. And this is the final element method that is done from the phase 2 analysis. It shows that this part, the interface between the soil and the rock is the maximum section has been formed along this soil and rock on this. And this is the PFAM with the mix. You can see the movement of landscape is taking place by changing the soil strength parameters in the wet condition and the failure condition. How the landslide is taking place. Let's see. This color indicates the velocity of the material. Okay, this is the movement at the top of this focus slide. And this is the bottom part of the landslide where the segment has been deposited. see the deposition process at the bottom of the landslide. And I have determined the thickness of the sediment over here in this one. And I have given some snapshots for different time settings. At the initial phase, the landslide was like this. This every grid is 50 meters long. And after all the 6th second, the landslide started to move. This is the initial. And around 20 seconds, the landslide took place like this. And at the end of the landslide, all the values were considered at the bottom of the landslide. And this is the sedimentation hypothesis time for the landslide at the bottom of the landslide. And these are the different bases I have put in. And at the 1 meter section, I have covered for 1 meter section. 1 meter section that's suitable for this area. That's why around 26 meters sediment has been formed at the bottom of the landslide. And this is the velocity graph. The maximum velocity was found to be around 19.6 meters per second. And this is the sedimentation in terms of mesh height and then in terms of geological. And last year, the mitigation measure was applied over here. And the dewatering was the main proposed. In order to keep the water table fixed for 9 meter to 15 meter, we're going to drain out the water from the ground. Drain out from the subsurface geology like this, and it has been channelized. We can see the different drill holes, so the drill holes from where the water is coming out. And it helps to reduce the water table. That's like before analysis. And it is the current situation. We can see the landslide having the status now by lowering the ground. And for the landslide, and the ground table was, in dry season was 5 meters below the existing ground level. And in wet season it was 1.5 meters only. And alien determines the factor of safety like this. And after applying the level and reducing the water table, the factor of safety is 1.26, and it's stable now. And the maximum resistance is 4.9 meters, and the maximum sediment deposition is 160 at the bottom of the landslide. The maximum velocity is 19.6 meters. And water table reduction is the suite of engineering structure based on the volume and the nature of the sediment and the movement pattern. That can be a solution for such type of slides.
Use FDM instead of FEM.
Sorry.
Considering that anisotropy and heterogeneity, as shown in the tomogram, that complex geology in that landslide that you showcased, would it have been better to use FDM instead of FEM?
Yeah, PFAM we use the homogeneous material. Yeah, as you said, in the PFAM, in the finite element method, we can use the heterogeneous analysis.
So the fuel segment rocks, making excavation challenging. The complex geological setup creates numerous stability problems. Within tunneling, posing a major challenge that must be scientifically addressed to ensure that tunnels are cost-effective, physical and safe. This is the previous case of total failure. It's the problem statement. There is non-total instability due to extensive slope cutting and weak weather cephalic rock formations. Limited geological and geotechnical characterization of mudstone and sandstone, affecting accurate stability assessment. Inadequate groundwater management and lack of effective drainage system, leading to increased instability during monsoon season. These are the photos showing Sitawaba tunnel total collapse before and after. Objective. I have divided the objective into two sections. The main objective of the research is to study the stability of total at Sitawaba tunnel, and the specific objectives are to assess the total stability with both analytical and numerical modeling, and to propose engineering solutions for enhancing total stability. Lab tests performed by concerned authority of the project. Proper engineering solution will be recommended. Project site description. The research area is located in the Lumini province, Kalpa district. The non-portal lies in the lower middle valley. It is located about 50 meter upstream from the Tinau Hyderabad dam site. The south portal lies in the lower Sima Lake, which is located near the Sita Baba temple. This is the location map of the study area. Geological setting. Young sedimentary rocks such as sandstone, siltstone and mudstone are the three main types of rock in this area. The rock of the north portal composed of thick bedded sandstone interbedded with the mudstone, while the rock of the south portal composed of thin to thick bedded, fine to medium grade sandstone interbedded with mudstone. This is the nearby sectional view of south portal, where colluvial soil at the top, fine to medium grade sandstone, interbedded of sandstone and mudstone, and interbedded of siltstone and mudstone, and the repetition of source here that we can see in the figure. This is the north portal cross section showing different here. Similarly, colluvial soil at the top, and medium grade sandstone, interbedding of sandstone and mudstone, and repetition of source layers that we can see. And this is the outcrop showing bedding of different layers near north portal. Dynamic analysis. This is the stratigraphic projection at north portal, where the north portal is suspected to be plain here. That is, there is daylighting condition and friction angle is less than slope of discontinuity, and also slope of discontinuity is less than L slope. This is the stratigraphic projection at south portal. The south portal seems quite stable. That we can see in the figure. Analytical assessment. Analytical assessment was carried out from Mottolm criteria for colluvial soil and using Barton-Prentice criteria for jointed rock mass. These are the input parameters for the analytical assessment, and the bar chart shows the result for analytical assessment at the north portal. At the north portal, analytical assessment was carried out for all static saturated and dynamic saturated condition. At the initial stage, that is before excavation, the portal is safe. That is, factor of safety is greater than 1. That we can clearly see in the figure. And at the first stage, before application of support, the factor of safety reduces below 1, and the stability of the portal decreases after the excavation. And at the second stage of excavation, the factor of safety, which is less than 1, but increases than previous stage. That is, factor of safety increases from the first stage without application of support. This is due to the benching effect. And at the third stage, the portal stability further decreases. That is, stability factor less than 1. That we can see in the figure. And at the right side, this is the result for south portal. Result of analytical assessment for the south portal. At the initial stage, before excavation condition, factor of safety is greater than 1. That is, portal is safe before excavation. And at the first stage of excavation, its factor of safety reduces less than 1. And at the second stage of excavation, due to benching effect, factor of safety further increases. And at the third stage, factor of safety at the same line, which is less than 1, but slightly decreases, then second stage excavation. Deterministic approach. Slope stability assessment was carried out from deterministic approach by using slide 2 software. These are the input parameter for the slide 2 software. And this is the result from slide 2 software. Here the initial condition, that is before excavation, factor of safety is greater than 1. That we can see in the figure. And here the first stage of excavation, factor of safety decreases below 1. And here the second stage excavation, factor of safety further increases due to benching effect at the figure. After the slope stability assessment from analytical method and numerical value method, the result are validated with finite element method. That is, the slope is analyzed by using RS2 software. These are the input parameters for the RS2 software, and these are the results from RS2 software. At the initial condition, that is before excavation, at the initial condition, before excavation, factor of safety is greater than 1. That is, reduction factor is greater than 1. It shows the slope is stable before excavation. And here the second stage excavation, first stage excavation factor of safety reduces below 1. That is, stress reduction factor is less than 1. It is 0.8. So the portal is unsafe after the excavation and before application of support. Here the second stage of excavation factor of safety reduces to 0.76, and here the third stage excavation factor of safety further reduces to 0.75. That we can clearly see from here. This is the outcome from all analytical, deterministic and numerical analysis. Here the initial condition, portal is safe, that we can see, and here the first stage excavation, portal is unsafe, factor of safety less than 1, and here the second stage of excavation, the factor of safety slightly increases due to bending effect, and here the third stage excavation, factor of safety further decreases and which is less than 1. It shows from the comparison of all analytical, elliptical value and finite element method, portal is safe before excavation, but after the excavation, it seems quite unsafe. The factor of safety decreases significantly as excavation progresses, indicating increasing instability, especially in later stages. From deterministic analysis, that is from elliptical value method, it shows the extreme instability with factor of safety dropping close to 0.5 in the third stage, suggesting possible failure without reinforcement. From numerical analysis, that is from analytical method, results indicate relatively higher stability compared to elliptical value method, highlighting the importance of stress redistribution in soil stability assessment. Analytical results remain relatively stable but still show a decreasing trend, emphasizing the need of additional support measures. These are the references that I have taken, and these are the site photographs taken during my site visit. Thank you.
The base cut inclination is vertical, right? So you optimize in the software whether by increasing or decreasing the inclination, you can have some effect on the factor of safety of that slope.
Bench cutting is perfectly horizontal.
Okay.
But at the first stage excavation, it is slightly inclined, but perfectly bench is horizontal.
Have you followed any norms regarding that? Excavation?
No. Yes, but design.
Okay, thank you. Second question.
यो कहाँको पोर्टल हो? नर्थ पोर्टल हो हैन त? अनि अर्को यतातिर फरवर्ड जान्छ साउथ हो नि त? अनि तपाईको त्यो प्रोफाइलहरु देखाउनुहुन्छ। हो यो त टोटली रङ छ नि तपाईले बनाएको। सबै रक चाहिँ नर्थ इस्ट डिपिङ छन्। यहाँ इन द स्लोप डिपिङ छन् रक बेडहरु, स्यान्डस्टोन, मिडल सिवालिका स्यान्डस्टोन, मर्स्टोनहरु। तपाईले सबै साउथ डिपिङ बनाउनु भएको छ। अनि यसरी बेकारमा यो मोडलिङ गरेर के फाइदा हुन्छ? मैले कम्प्लिटली बुझिन के एकदम इम्बेरेसिङ भयो के हो। किन यत्रो जियोलजिस्ट यहाँ बसिराख्नु भएको छ। तपाईले पुरै टोटली रङ देखाइराख्नु भएको छ कि अर्को देखाउनु स्लाइड। अर्को स्लाइड देखाउँछु यहाँ पनि हेर्नु सबै आउटवर्ड सबै डिपिङ सबै रकको आउटवर्ड डिपिङ देखाइराख्नु भएको छ जबकि इनवर्ड डिपिङ छ सबै नै रक। अर्को देखाउनुहोस्। अर्को देखाउनुहोस्। होइन फरवर्ड जानु फरवर्डमा। अर्को अगाडि जानुहोस् अगाडि जानुहोस् अगाडि जानुहोस् अगाडि जानुहोस् अगाडि जानुहोस् पछाडि आउनु तपाईँ। अर्को हो यहाँ पनि हेर्नुहोस् सबै तपाईँले आउटवर्ड डिपिङ रक देखाइराख्नु भएको छ। अर्को देखाउनुहोस्। अर्को देखाउनुहोस्। अर्को देखाउनुहोस्। अर्को हो हेर्नुहोस् सब आउटवर्ड देखाइराख्नु भएको छ जबकि फिल्डमा रक इनवर्ड डिपिङ छ। त्यसैले यो त केही पनि भएन नि त। त्यसैले कमसेकम बेसिक कुरा त तपाईँले पहिला प्रपरली राख्नु पर्यो नि त। रक त त्यो सिद्ध बाबामा हाम्रो विद्यार्थीहरू सबै जानुहुन्छ त्यो सबै नट डिपिङ रक छ। अब तपाईँले त्यसलाई साउथ डिपिङ बनाउनु भयो भने त त्यो एनालिसिस कसरी मिल्ला?
स्ट्राइक लाइन थाहा भएन डिप 70
त्यसमा यस्तो छ एक्सेप्सन गर्दाखेरि एउटा चाहिँ सिधै पोर्टलतिर अर्को चाहिँ साइडतिरको एक्सेप्सन भएको छ। मैले चाहिँ ठ्याक्क पोर्टलको अगाडिको एक्सेप्सन देखाएको साइडतिरको एक्सेप्सन देखायो भने डिपिङ चाहिँ अर्कोतिर हुन्छ यसको।
त्यस्तो आउँदैन किनभने त्यो हामीले के थाहा छ एपरेन्ट टिपको कुरा गर्ने भने अलमोस्ट होरिजन्टल हुन्छ होला होइन तर नर्थ टिपिङ बेडहरू छन् सबै नर्थ इस्ट टिपिङ बेडहरू छन् तपाईँको यहाँ झन् 30 डिग्री सेन्टिग्रेड यहाँ अहिले चाहिँ अलरेडी चाहिँ अनि तपाईँको फोटोमा त नर्थ टिपिङ छ नि त बेडहरू फोटोमा तपाईँ फोटोमा त नर्थ टिपिङ देख्छ नि त त्यसैले यो मिलाउनुहोस् मलाई लाग्छ यो मिलेकै छ
Okay, thank you. You can discuss in lunch break. Thank you very much.
Geophysical tool is a direct method to evaluate surface lithology and their thickness, compactness, and depth to its upper layer, that means overburden. Collected information either by direct or indirect method assists the engineer to locate and design the foundation of engineering structure accurately. First, to conduct geotechnical investigation is comparatively expensive than non-destructive method. We know that. The allocation of investigation budget is comparatively low in case of developing country such as Nepal. In case of transmission line alignment, I am focusing on that. There is a more number of foundation design. There should be design, but the investigation is very low. We have to compare or interpolation or extrapolation or averaging the value of this exact value, and we have to given them data to design the foundation or to analyze the liquefaction potential such that. To overcome such problem and increase data density, the empirical relationship will be beneficial. This research is aimed to establish the relationship between the electrical resistivity and several geotechnical parameters in form of an empirical relationship. For that case, I have used 41 tower locations. Among these, 21 are in Siwalik, residual and colloidal deposit, and 21 are situated at quaternary deposit of Tarai plain. Total 58 soil samples are tested in laboratory to calculate the geotechnical parameter of soil. Now location, the study area is located along Sunol to Longmai section of New Portal 400 kV transmission line alignment. Total 42 tower locations are chosen for the analysis. Among them that I have already told that. Then my objective is to carry out the field investigation work to acquire geotechnical parameters, that is by direct method and resistivity, indirect method of subsurface strata to establish the empirical relationship along the study area. Exploratory drilling, core drilling, there are a total 5 number I have taken, 5 number of core drilling data and 37 locations of test pit data with the standard penetration test and laboratory test of soil sample derived from SPT sample to calculate the geotechnical parameter. Soil resistivity test of 42 respective locations are used for the analysis. Now methodology, I have used direct and indirect method. Indirect method, I have adopted the test pitting method. The maximum dimension is 3:3, and borehole drilling. The maximum depth of borehole drilling was 15 meters at that time, but I have taken the data only up to 10 meters because the resistivity data, our resistivity data is up to only 10 meters. So to correlate these two values, I have taken this 10 meter depth value. Now this is just example, this test pitting and drilling direct methodology. This is sample of drilling and sampling. There is SPT in this section. I have taken the sample from this SPT test. In case of drilling, and this is test pit sample. Then I have taken the soil sample by this method also. Then this is the format of our laboratory test where the depth, natural moisture content, dry density, wall density, so particle size analysis, heterovolemic switching gravity, direct shear test was done. At that time, among these values, I have taken C, fine content, dry wall density, and moisture content for my analysis. Now I have moved to the indirect method, this geophysical method to calculate the resistivity of soil. I have used AENC or test model 6472. Then I have used Weiner-Foucault arrangement system to acquire the field data. This is the sample result. We have used two directions, north, south and east, west direction to carry out the resistivity of the soil, and the averaging value is adapted for the analysis. Now, result and decision this value, then we can correlate and calculate the other unknown parameter. Relationship between moisture content and resistivity. If the moisture content is high, the resistivity will be low. This is inverse relationship. According to that, this is also this shows the power relationship between moisture content and resistivity. This R-square value is 0.6821. Next, wall density. That means if the density is increased, the resistivity, then this R-square value is 0.5031. The relationship between fine content and resistivity. If fine content of the soil is high, the resistivity is low. And total 58 soil samples are tested in lab for angle of internal friction, cohesion, moisture content, fine content and raw density. Weiner-Foucault arrangement is used to acquire the data from the field, and then north, south and east, west direction is adapted for the calculation of resistivity value. And 5 empirical relationships are established in research for the study area. That my aim is there is 442 tower. We have to design the tower location there, but only 100 tested are done. Behind this 342, we have to given them data without any method. If we have such type relationship, if there is nothing, something will be helpful for the design parameter. On the sense of that, I have established such type of parameter, and I have already shown in graph. Now there are some limitations of the study. This is disturbed sample I have taken for the calculation of geotechnical parameter instead of undisturbed sample. The depth of water table is not observed during the field investigation because this water table directly influences to the resistivity of the soil. So in this case, we don't outline the water table depth. Then field data acquisition season is after the monsoon season, from October to February, because in case of monsoon season, the resistivity value is increased rather than the dry season. Thank you.
You have used altogether 42 data as
42 locations, 58 soil samples.
Okay, so that is it enough to establish the relationship in the quaternary deposit?
Yes,
My first question. And regarding that, if there are similar sort of correlation or relation established previously, so you should have just compared and correlated whether your parameters are within the range of previous studies or not. I didn't find it in your presentation. And the most fundamental question is that you have just ascertained the alignment, ERT line, right, in north, south and east, west direction. That is not the practice. Generally, if there is a hill slope, the practice is you have to align the ERT along the contour and across the contour. That in that way we will also consider the groundwater flow regimes. So that you are bounding the ERT line in a north-south, it is a very bad approach, I think.
That in my context, the north, south and east can minimize the defect of this value, I think. Then thank you for your comment and the suggestion. That this value, this data is, I feel, not enough for the empirical relationship. But this is just practice. I have collected more data, if possible, from other part of our body. Then I'll increase the R square value, because there are only are 58 samples. Yeah, right? The next one.
Yeah, thank you. Next question. Okay, thank you. Thank you, Nina. Now I like to invite
Really rock mass classes with actual rock mass classes in precise suggestion of New York Library project. For the presentation, our presentation has been outlined into 6 topics: introduction, project description, geological setting, rock support design, predicted versus actual condition, and conclusion. Nearapala Hydroelectric project is the run-of-type river project. It is located in Kathmandu district in Cochin province and it has the capacity of 50 megawatts. The design discharge of Nearapala Hydroelectric project is 30.48 meter cube per second and gross height is 206.60 meter. The project has diversion tunnel which is 4.8 kilometer, which will transport Nearapala from Tukima to powerhouse at Khundin. The diversion scheme includes 30 meter long diversion way, intake, gravel trap, approach culvert, settling machine, headrest pipe, surf and 531 meter finished pipe. This is the headers of the project site. This is the powerhouse site, and we can see this is the surf which is 8 meter diameter after completion of concrete, and excavation size is 9.2 meter. This is the penny circle line beam, and we can see somewhere this is the outlet portal. For the construction of this project, there was 3, 1 audit and 2 inlet and outlet portal. This is the audit portal from where the excavation was carried out, and upstream and downstream portion were excavated. Similarly, this is the outlet section and this is the inlet section. Geologically, this project lies in the Central Himalaya and it lies in Kathmandu windows. The main rock type that we encounter in the project area is avenite and schist, and the MCD lies 1.5 kilometer above the project area. This is the location of the project area. This is the surface geological mapping, and this is the cross section of the tunnel. As I have already mentioned that the rock type that encountered in the project is organized and schist. The major groups are only 2 types of rock mass have been encountered. 25% of the total alignment of the rock mass that consists of organized and 75% of the rock mass that consists of schist. The maximum and minimum overburden that encountered in the tunnel alignment is 376 meter, and the minimum rock cover that encountered in the headers tunnel is 160 meter. Similarly, the side cover is 200 and 450 meter. For the analysis, we have done the joint analysis, and we have encountered fake plus random transits. Similarly, to characterize the rock mass, detailed parameter of Q and RMR has been analyzed, and for the classification of rock mass for the Nearapala, as we look to the chart of the Q system, the rock mass lies from very poor to poor rock mass. Similarly, if we see the chart for RMR, it classifies poor rock to fair rock. The RPQ value that ranges in the project area is 30 to 80. Similarly, the RMR value is 31 to 60, and Q value ranges from 0.013 to 1. Steel line section. For inlet tunnel there is 35 meter, and in the outlet tunnel there is 100 meter of steel line section has been erected. After the 100 line of steel line has passed, there is the concrete line section of 100 meter, so that in the future there might not be possible leakage of the tunnel. And in the section where in the inside of the tunnel where there is the water leakage and possible zone of the water leakage from the tunnel, the grouting has been done. This is the section that we have carried out the concentration grouting, so that there might not be the water leakage from the tunnel, and from the groundwater, from the groundwater also the water leakage might be goes to the inside the tunnel. This is the targeted works of the action construction plan that has taken from Nevakola hydroelectric project for the completion. It shows that the predicted time does not actually vary during the construction of the project. And as we see here in the graph, we can see that the construction time has ranges from 12 months to around 15 months. The construction time has been extended to complete the project. This is the systematic, this is the geological cross-section of the maps that shows that as for design and as for actual construction, there is the variation in the rock type, so that the time has increased, and similarly the support maps that we use in the tunnel has been changed, so that the consequences that happen is that the time and the cost has been expand and increases. This might has causes that during the pre-construction stages, during the design stages, the proper geological mapping and geological investigation has not been done, so that during the construction we face that the rock mass that has been written in the document and the cross-section and the support type that has been written in the document is does not actually matches with during the construction. During we know that during the study area, we can say that it does not match actually, but what is our duty is that we have to minimize the variation. This is the chart that shows that there is a change in variation in rock type, similarly in crust and in the support system that applied for the heavy tunnel. As you see that in rock classes during the time of as per design, we have shown that there is a rock class we encounter in the heaviest tunnel. But okay, sir. But as you see here, during the construction and actual during the time of construction, we face that we did not found any rock class 1. So that what happens is that during the design, every designer will place the support system minimum in the rock class and maximum in other types. So we see that there is a variation in rock class as for design and as for actual. This makes the difference that the time and the cost that during the detailing in design what we expect has changed, and this is ultimately causes the consumption of support types that we use in the tunnel. We can see the variation of support system that we use in the tunnel, like grouting, reinforcement, concrete, steel beams, rock bolts, and steel fibers have changed. This ultimately brings the increasement in the cost variation. Similarly, from this study, we can say that the review of predicted rock mass quality versus actual rock mass and predicted rock mass versus actual rock mass in heavy tunnel of Nevakola hydroelectric shows considerable variation. This variation ultimately influences the project cost and time. To minimize the reference variation, as already stated, the degree of geology and geological investigation that should be carried out at the time of reconstruction and during the construction time should be upgraded. As a result, initial investigation costs may rise slightly higher, but it ultimately gives the accurate data, project cost and completion time during the time of construction, so that the investor, which is investing the money for the construction of this hydropower project, can make up that this must cost my range for my project. Thank you, sir.
We can take only one.
Predicted and the actual, right?
Yes.
In the tabular form, if you could have said that rock class 1 you did encounter, but in the prediction there was a rock class 1.
Yes.
But if tabular form would have been given, then we could have find that what is the difference in each rock classes that you encountered, and what was the support system that you said that the developer needed more tunnel support cost, right?
Yes.
So what was that also in that analysis, if you could have put in your presentation, then it would have been very fruitful.
Okay, actually is there the first very the support map you can see here that we have encountered in the project area during the construction and during the design. Similarly, here we can see the chart that reveals that how much rockworks has been encountered and how much rockwork, concrete and grouting has been placed in the tunnel can be seen from here.
Okay, thank you.
Thank you, sir.
Okay, thank you for your presentation.
Similarly, Rapporteur Kendra Lamsha, please.